So we are now in Chapter 4 of Mechanics 107, and it is all about shear and moment in beams. So we will focus on the structural element, which is the beam, and we will study the bending loads in which the loading effects vary from section to section of the beam. So these loading effects take the form of a shearing force and a bending moment. So we will be encountering the shearing force and bending moments of the beam that is referred to as the shear and the moment. So a beam is a bar that is subjected to forces or couples that lie in a plane that contains the longitudinal bar. So we have two types of beams according to determinacy. First, we have the statically determinate beams. So what are statically determinate beams? So these statically determinate beams are the beams in which the reactions of the supports may be determined by the use of the equations of static equilibrium. So ano ba yung equations ng mga static equilibrium? So we have three equations: the summation of forces horizontal, the summation of forces vertical, and then the summation of moments. And then we have different kinds of statically determinate beams depending on the supports. So first, we have a simple beam. So simple beam is supported by a hinge reaction. So this part is a hinged support and a roller support at the other end. So this is called a simple beam. So this beam is loaded by a point load. So pwede din na uniformly distributed load yung nakalagay dito, or a uniform varying load. So yung uniform varying load naman is magkaiba yung load niya from a certain point to another point. So for example, this one, we have here 20 kilonewton per meter, and this one we have 0 kilonewton. This is called a triangular load or a uniform varying load. So ito naman, this is a uniform distributed load in which at this part to this point, uniform lang yung load niya. So this is called a simple beam. Again, it is supported by a hinge support and a roller support at the other end. So another one, we have a cantilever beam. So a cantilever beam is supported at one end only. So ito lang yung support ng ating beam, in which it is restrained or it is in a fixed support. So this fixed support is suitable to restrain or to prevent the rotation of that end. So at this part, at this fixed support, meron tayong three reactions here. We have moment, forces or vertical force, and then the horizontal force. So at this part, hindi lang nakalagay yung horizontal force because there is no other horizontal or external force that is acting on our beam. So this is an example of a cantilever beam. Overhang yung another end, and then the other end is a fixed or a restrained support. So fixed support at this part. So again, pwede to point load or a uniform varying load, or a combination of a point load and a uniform varying load. So depende na lang sa situation. So this is an example of cantilever beam, fixed support at the other end. And then another one is an overhanging beam. So an overhanging beam is supported by a hinge again and a roller support, but it is extended beyond the support. So meron tayong certain distance na naka-extend from our support. So ito yung overhang na tinatawag. and then it can be loaded depending na rin sa situation. So this example, it is loaded by a point load at the other end and a uniform distributed load at the mid part. So we have here overhanging beam. So these three types of beam is called statically determinate beams, and the reactions can be solved using the three equations of equilibrium. So the summation of forces horizontal, summation of forces vertical, and then the summation of moment. So masasolve natin yung mga reactions through these three equations lang. So next type of beam is the statically indeterminate beams. So these beams, if the number of reactions exerted upon a beam exceeds the number of equations in static equilibrium, the beam is said to be statically indeterminate. So hindi nakakasya yung three equations natin for static equilibrium. So hindi na sapat yung summation of forces horizontal, summation of forces vertical, and summation of moment to solve for the reactions for statically indeterminate beams. So in order to solve the reactions of the beam, the static equations must be supplemented by another equations based upon the elastic deformation of the beam. So the degree of indeterminacy is taken as the difference between the number of the reactions and the number of equations in static equilibrium. So we have R is equal to 3 multiplied by n, in which the R is the number of reactions present in the beam, and then yung n natin is the number of members. So if R is equal to 3n, yun yung tinatawag natin na statically determinate beams. But if our reaction is not equal or is greater than 3n, dito na papasok yung statically indeterminate beams. So we have different examples or situation kung saan natin makikita yung statically indeterminate beams. So first example is a propped beam. So prop beam, kung mapapansin nyo, at the other end, this is in fixed support, restrained at this part, and then the other end is supported by a roller. So this figure shows a uniformly varying or a triangular load, and then the intensity of loading increases or decreases at a constant rate. So yan, increasing yung ating load at this part. And this is called a prop beam, fixed at the other end and then supported at the other end by a hinge support. So for example, this one, we have here at the fixed support, we have 3 reactions, so and then another one here. So R is equal to 4, and then yung number of a member is 1. So 4 is greater than 3 multiplied by 1. So difference nila is 1. Therefore, this beam is statically indeterminate in the first degree. So this prop beam is statically indeterminate in first degree. Another one, we have a fixed or restrained beam. So fixed or restrained beam in which both ends is fixed or restrained. So both end na it is restrained support or fixed support. So for example, we have here 3 reactions and then 3 reaction and then 1 member. So yung R natin is equal to 6, N is equal to 1. Therefore, 6 is greater than 3 multiplied by 1. So this fixed or restrained beam is statically indeterminate in second degree. So this fixed or restrained beam is statically indeterminate in the second degree. So another one is a continuous beam. So dito sa continuous beam, makikita nyo, it has several supports. So for this example, we have 3 rollers and a hinge support. So, continuous yung support within the length of the beam. So, this is a combination of a uniformly varying load and a point load. So, the loading can also be non-uniform. So, at this part, you have here, so sa roller support, you have one reaction, and then at hinge support, you have 2 reactions. Therefore, we have 2, 3, 4, 5. So, our R is 5 and our N is 1. Therefore, 5 is greater than 3. So, this is statically indeterminate in second degree. So, this continuous beam is statically indeterminate in the second degree. So, please take note that a concentrated load, so for example, this concentrated load is one that acts over so small or a very small distance that it can be assumed to only act at a certain point. Kaya tinawag na point load yung concentrated load natin. Ina-assume na lang natin na it is acting at a certain point because it acts over so small a distance. And then a distributed load acts over a considerable length of the beam. So for example, this uniformly varying load, it has a certain distance. And then yung point load, consider lang natin kung ano yung position niya on the beam. Next, how will we draw the shear and moment diagram? So, example, we have here a beam that is simply supported. This is a simply supported beam and it is loaded by a concentrated load or a point load. So, to be able to determine or to draw the shear and moment diagram, we will pass an exploratory section AA over here at a certain distance x from the leftmost part of the beam. So, passing an exploratory line AA divides our beam into 2 segments or into 2 parts. So, i-drawing lang natin yung diagram at the left part of our exploratory section. So, we have exploratory section AA, and then this is the distance x, and then reaction 1. So, to satisfy or to maintain equilibrium, the fibers in the cutting section supply the resisting forces needed to satisfy the conditions of the static equilibrium. So, in this case, the summation of forces along horizontal is equal to 0 because there is no other horizontal forces acting on the beam. And then the summation of forces vertical is equal to 0. R1 requires a certain fiber on this part to create a resisting force called resisting shearing force. So, at this part, meron tayong force called resisting shearing force. So, let's say this is our force downward and it is our resisting shearing force. So, this resisting shearing force create a force to resist our R1. So, kung isa-sum up nyo yung summation of forces vertical, R1 is basically or numerically equal to our resisting shearing force. So, magkaiba lang yung direction niya but the magnitude is the same. So, we have now our equation for resisting shearing force, in which our resisting shearing force is equal to the summation of forces vertical at the left part of the exploratory section. So, the subscript L emphasizes the vertical summation of forces at the left side of the beam segment. So, isa-sum up nyo ang lahat ng vertical forces acting on the left side ng ating exploratory section. So, kindly take note of this formula for our shearing force. So, in computing shear, upward forces or loads are considered positive. So, take note of that. Upward forces or loads are considered positive. So, this rule of sign produces the effect as shown, in which a positive shearing force tends to move the left segment upward with respect to the right. So, positive shear tends to move the left side upward with respect to the right side, and then vice versa for negative shear. So, negative shear tends to move the left part of the beam in a downward motion with respect to our right. So, to complete the equilibrium of the free body diagram, we will take the summation of moments to balance R1 and BR. So, we will take a couple M or a couple moment at the cutting section. So, our M now is equal to R1 multiplied by the moment arm, which is X, in counterclockwise direction para mabalance yung ating beam. And then at this portion, left side lang yung drawing ko. So, we will draw the left segment of the beam. So, this is called now our bending moment because it tends to bend the beam. So, for the right segment ng ating beam, we have here the reaction 2 and then a point load T. And then, here we have a downward force. Therefore, at this section, we have now upward portion or upward motion ng ating resisting force. And then, this is in counterclockwise direction. So, most probably, it will be in clockwise direction now. So, our couple M is now in clockwise direction. So, the summation of moments about the centroidal axis of any selected section of all loads acting either on the left side or on the right side of the section is called the bending moment, in which our bending moment is now equal to the summation of moment at either left or either right side of the segment or of the exploratory section. So, kindly take note of these. These are the curvatures corresponding to signs of bending moment. So, we have positive bending moment and the negative bending. So, the positive bending, upward acting external forces cause positive bending moment with respect to any section. So, downward forces cause negative bending moments. So, this is negative. So, again, upward acting external force causes a positive bending moment with respect to any section, and downward forces cause negative bending moments. So, to sum it up, we have here 4 steps in drawing the shear and moment diagram. First, we will begin by computing the reactions in the support. So, i-solve muna natin yung mga supports or the reactions in the supports. Second step is to pass an exploratory section between two supports starting on the left side to create segments. So, for example, yung kanina, we have a simply supported beam. You will create exploratory section to create segments. So, for example, we have here simply supported beam and then point load at this part and then point load din dito. So, it will create 3 segments. You will pass an exploratory section AA, exploratory section BB, and then exploratory section CC. So, we have 3 segments at this part. And then, the third one is to apply the definitions of vertical shear and bending moment through this equation para makabuo kayo ng shear equation. And for the fourth step, you will compute the shear by considering only the external forces lying to the left of the exploratory section. So ito yung tinutukoy niya, whereas the moment may be computed by taking moments about the exploratory section caused by the external loads. So define ko lang again. So this is yung exploratory section natin. For example, you have here different forces, and you will sum up all the shearing forces that is acting on the left part of the segment. And then yung ating moment, you will take the moment at this segment. So be careful in assigning signs. Plus signs to shear and moment caused by upward acting loads, and minus signs to shear and moment caused by downward acting loads. So to be able to understand better, we will now proceed to our examples. So for our sample problems, we will write the shear and moment equations of the beams loaded as shown. And afterwards, we will sketch the shear and moment diagram of each beam. So for our example number 1, we have a beam that is loaded by 30 kN and 50 kN load that is directed downward, and it has two supports at B and at D. So solving first the value of the reactions at D by taking the summation of moment at D is equal to 0 clockwise positive. So we have negative 30 kN. The moment arm, we have 6 meters from 30 kN to the reaction at D, plus the reaction at B. Moment arm is 5 meters minus 50 kN. Moment arm is 2 meters is equal to 0. So solving for the value of the reaction at B, so we have 56 kN. And then for the value of the reaction at D, we will take the summation of forces vertical is equal to 0, upward positive. So we have negative 30 kN plus the reaction at B, 56 kN, minus 50 plus RD. Therefore, the reaction at D is equal to negative 24, so transpose natin magiging 24 kN. And then our next step is to pass an exploratory section between each segment. So here we have 4 segment AB, 3 segment rather, segment AB. So we have exploratory section AA, and then BC we have exploratory section BB, and then at CD we have exploratory section CC. So first, for exploratory section AA, we have segment AB. So drawing lang natin yung segment at the left part ng exploratory section A. So, i-draw natin ulit yung segment that is at the left part of the section AA. So, we have 30 kN, and then the distance from the leftmost part to section AA is considered as X. So, we have our formula for shear. So, taking all the vertical forces at the left part of A, so we have negative 30 kN, and then taking the moment at section A, we have negative 30, moment arm is x. So we have negative 30x kilonewton that meter. And then for BB, for section BB, so ulitin lang natin, ito-draw natin lahat ng forces that is acting on the left part of the exploratory section BB. So this is our x, and then between the first segment is 1 meter. So the shearing forces at segment BC, we have negative 30 plus 56. So it is equal to 26 kilonewton. And then taking the moment at the left part of our exploratory section, we have negative 30, moment arm is x, plus 56, moment arm is x minus 1. So simplify natin, we have negative 30x plus 56x minus 56. Therefore, we have 26x minus 56 kilonewton that meter. And then for the last segment, so same process lang. Taking all the shearing forces acting on the left part of our exploratory section C. So this is now our x. Tapos meron tayong 1 meter. And then we have here 3 meters. So for the shearing forces at the left part, we have negative 30 plus 56 minus 50. So we have negative 24 kilonewton. And then for the moment, we will take the moment at the left part. So we have negative 30, moment arm is x, plus 56, moment arm is x minus 1 meter. Minus 50, and then the moment arm is x minus 4 meters. Therefore, simplify natin, we have negative 30x plus 56x minus 56 minus 50x plus 200. So it is equal to negative 24x and then plus 144. And now we are ready to draw the shear and moment diagram. So we have our shear diagram and then moment diagram, and then positive, negative. So for the first part, the shear at segment AB, we have negative 30 kilonewton. So negative 30, nasa baba siya ng ating origin. So negative 30. So yung negative 30 kilonewton hanggang kabuuan ng segment AB. And then for BC, same 26 sa kabuuan ng segment BC. So 26 kilonewton. So all throughout segment BC, we have 26 kilonewton. And then for segment CD, negative 24 kilonewton. So nasa baba siya ng origin. So we have negative 24. And it will run all throughout segment CD. connect lang natin yung dots for our shear diagram. So this is now the illustration of our shear diagram, in which kung makikita nyo, on the last part we have 24 kilonewton, and at the last part we have negative 24. So yan, parehas lang. Same through at the first part we have 30 kilonewton, and at the shear diagram we have negative 30. So mag-close yung diagram talaga natin. And then for moment, and for the moment diagram, so for the moment at segment AB we have negative 30x kilonewton that meter. Ang gagawin natin dyan, yung segment AB we have a distance 0 to 1 meter. So for the first part, sasubstitute lang natin yung x with 0. So negative 30 multiplied by 0, so 0 kilonewton that meter. And then at the distance of 1 meter, so negative 30 multiplied by 1, magiging negative 30 kilonewton that meter. So ito yan. And then for segment BC, gagamitin natin tong formula na na-solve natin kanina. We have 26x minus 56. So at distance x is equal to 1 meter, we have negative 30. And then at distance x is equal to 4 meters, we have 48 kilonewton that meter. And then for the segment CD, we will use this formula. Negative 24x plus 144, and the distance x will be equal to 4 meters. Pag-substitute natin ng 4 meters, so magiging 48 kilonewton that meter. And at x is equal to 6 meters, magiging 0 kilonewton that meter. So nag-close ang ating moment diagram. At this part, we have a 0-degree curve. So, itong moment diagram natin, this is a straight line with a 1-degree curve. So, ito yung hinahanap ng problem, yung shear and moment equations and the shear and moment diagrams. For the next example, we have here a beam that is loaded with a uniform distributed load with 20 kilonewton per meter and negative 30 kilonewton. So, solve muna natin yung reactions at A and C. By taking the summation of moment at C is equal to 0, clockwise positive. So, the reaction at A, yung moment arm natin is 10 meters minus 20 times 5, and then moment arm is 5 plus yung distance from the centroid ng ating rectangle, so 5 divided by 2, so 2.5 plus 30, moment arm is 4, so it is equal to 0. Therefore, the reaction at A is equal to So it is equal to 63 kilonewton. And then for the reaction at C, we will take the summation of forces vertical is equal to 0, upward positive. So we have 63 minus 20 multiplied by 5 plus RC minus 30 is equal to 0. Therefore, the reaction at C will now be equal to 67 kilonewton. And then, next step is to draw or pass an exploratory section between each segment. So, we have 3 exploratory sections. So, for section AA, redraw lang natin yung forces that is acting at the left part of section AA. So, we have 20 kilonewton per meter, a uniform distributed load, and yung distance, x, from the leftmost part ng ating beam. And then, the reaction at A, which is 63 kilonewton. So, the shear equation, taking all the forces at the left part of our exploratory section. So, we have 63 minus 20 multiplied by x. And then, for the moment, we have 63x minus 20x. And then, moment arm, x all over 2 is equal to, simplify, 63x minus 10x squared kilonewton that meter. And for segment B, same process. So we have here again 20 kilonewton per meter, and then reaction at A is 63 kilonewton. And then we have a distance x. Reaction at A is 63 kilonewton. So the shear equation for segment BC, we have 63 minus 20 multiplied by 5. Therefore, it is equal to negative 37 kilonewton. And then for the moment, segment BC, we have 63x minus 20 of 5 meters, and then moment arm is x minus, kalahati nito is 2.5, so x minus 2.5. Therefore, the moment at BC is equal to 63x minus 100x plus 250. Then, simplify pa natin. So, magiging negative 37x plus 250 kilonewton that meter. And then, for segment C, or for our section C rather, we have here 5 meters and then another 5 meters between B and C. So the shearing equation, so it is equal to 63 minus, or yes, plus 67 minus 20 multiplied by 5, so it is equal to 30 kilonewton. And for the moment at segment CD, we have 63x plus 67 of x minus 10 minus 20 multiplied by 5, and then the moment arm is x minus 2.5. So simplifying it, therefore we have 130. Meron palang 100 doon. So, we have 30. We have 30x minus 420 kilonewton that meter. So, always remember to put the units. So, next step is to draw the shear and moment diagram. So, extend lang natin yung line in each segment. So, we have our origin, upward positive, downward negative. And then, shear diagram, moment diagram. And this is our load diagram. So, for the first part, for the segment AB, substitute lang natin yung 63 minus 20x, yung x with 0, since yung segment AB natin is lying on distance 0 to 5 meters. So, 0 maging 63 kilonewton, and then at x is equal to 5, is equal to negative 37 kilonewton. And then for the next part, for the BC, have negative 37 kilonewton, and it lies all throughout segment BC. And for CD, we have 30 kilonewton. So 30 kilonewton is lying all throughout segment CD. So we have here a 1-degree curve, since the uniformly distributed load is in a 0-degree curve. And then connecting the dots. So we now have our shearing diagram, or the shear diagram. And then if you want to determine the position of the zero shear, isa-substitute lang natin yung equation, or equate lang natin yung equation natin into 0 para ma-determine nyo yung position ng zero shear. And the zero shear, dito matatagpuan yung maximum moment natin. So, kindly take note of that. Kung saan yung zero shear, doon matatagpuan yung maximum moment natin. So, for our moment diagram, so for moment AB, substitute lang natin yung x natin with 0. So, 0. 0 yung moment natin at point A. And then, at point B, x is equal to 5 meters. Moment is equal to 65 kilonewton that meter. And if you want to determine the moment at this part, which is the maximum moment, substitute lang yung x with 3.15 meters. Therefore, the maximum moment is equal to 99.225 kilonewton that meter. So, yan na yung maximum moment natin at zero shear. Next, for segment BC, substitute natin yung x with 5 meters and then 10 meters. So, at 5 meters, we have 65 kilonewton. And at x is equal to 10 meters, we have negative 120 kilonewton that meter. And then, for the segment CD, substitute na lang yung x with 10 meters and 14 meters. So, at x is equal to 10 meters, it is equal to negative 120 kilonewton that meter. And at x is equal to 14 meters, we have 0. So, makikita nyo, nag-close na ang ating moment diagram. And since it is a 1-degree curve, yung moment diagram natin would now be in a 2-degree curve. And please take note of this, that if the shearing or if the shear is decreasing, the moment diagram is concave downward. And if the shearing stress is increasing, the moment diagram is concave upward. So at this part, since yung shearing diagram natin is decreasing, it will be concave downward. And we have 0 degree at the shear diagram. So at this part, we have 1 degree curve. So straight line lang yan. And then at this part, we have straight line then, which is a 1 degree curve. So at this part, it is already 2 degree curve that is concave downward since the shearing stress is decreasing. So take note of that. If the shearing stress is decreasing or the shearing diagram is decreasing, the moment diagram is in concave downward. Otherwise, it is concave upward. So for the next example, we have here a beam that is loaded with 20 kilonewton and it is in a restrained position or restrained support at C. So kung fixed support, we have three forces actually that is acting on it. So we have moment, vertical force, and a horizontal force. But since we don't have horizontal force, pwede nating i-neglect yun and only consider the moment and the vertical force. So to be able to determine the values of this one, we will take first the summation of forces vertical is equal to 0, upward positive. So we have negative 20 plus VC. Therefore, the vertical force at C is equal to 30 or 20 kilonewton. And then taking the summation of moment at C is equal to 0. So we have negative 20, moment arm is 6. And then at point B, we have a moment there which is equal to 80 kilonewton that meter, positive kasi clockwise yung orientation, plus moment at C is equal to 0. Therefore, the moment at C is equal to 40 kilonewton that meter. So moment at C is 40 kilonewton that meter clockwise, and then vertical force at C is equal to 20 kilonewton. And then we will pass an exploratory section at segment AB and segment BC. So for exploratory section AA, so same process kagaya kanina. We will draw all the forces that is acting on the left part of the segment, or the section rather. So we have 20 kilonewton and then a distance x. Therefore, the shearing forces or the shearing force at AB is equal to negative 20 kilonewton, and then the moment at AB is equal to negative 20x kilonewton that meter. And then for our segment BB, so same, we will draw the forces acting on the left part of the exploratory section. So we have here our x, and then 4 meters. So this is x minus 4. Therefore, the shearing equation is equal to negative 20 kilonewton. And then for the moment at BC, it is equal to negative 20 moment arm x plus 80 kasi clockwise siya. So plus 80 kilonewton that meter. And then we have now our equations. So we are now ready to plot the shear and moment diagram. So this is for our shear diagram and then moment diagram. So the process is paulit-ulit lang. You only need to review on how to sum up moments and vertical forces. And then so at segment AB, we have negative 20 kilonewton all throughout the segment. Negative 20 kilonewton, and same with segment BC. All throughout segment BC, we have negative 20 kilonewton. So, yan. Pare-parehas from segment AB to segment BC, we have negative 20 kilonewton. So, this is now our shear diagram. And then for the moment at AB, yung x natin will be equal to 0 to 4 meters. So, at 0, of course, moment niya is 0. And then at x is equal to 4 meters, moment is negative 80. And for segment BC, we have negative 20x plus 80. Substitute lang natin yung x with 4 meters and 6 meters. So, at x is equal to 4 meters, it is equal to 80. 0. So, at x is equal to 4 meters, the moment is 0. And then, at x is equal to 6 meters, the moment is equal to negative 40 kilonewton that meter. So, this is now our moment diagram. So, this is a 1 degree curve since yung shear diagram natin at the first part is a 0 degree curve. So, our moment diagram is in 1 degree curve. So, ito na yung ating moment diagram. So, mapapansin nyo, yan equal lang yung mga forces natin at section D. So, dun yung makikita na tama yung sagot ninyo. For the next example, we have a beam that is loaded with a uniform distributed load of 10 kilonewton per meter and an 80 kilonewton load. So, taking the summation of moment at C para makuha natin yung value ng reaction at A. So, we have RA, the moment arm is 10 meters, minus 80 multiplied by moment arm, which is 8 meters, minus 10 kilonewton per meter. Length is 10 meters, and then moment arm is 10 divided by 2, yung centroid. So, it is equal to 5 meters. It's equal to 0. Therefore, the reaction at A is equal to the reaction at A is equal to 114 kilonewton. And then we will take the summation of forces vertical is equal to 0 para makuha natin yung value ng reaction at C. So we have 114 kilonewton minus 80 minus 10 is equal to 0. So 10 and then 10 meters. Therefore, the reaction at C is equal to equal to 66 kilonewton. And And then we will pass an exploratory section in each segment again. So for section AA, we have a uniform distributed load of 10 kilonewton per meter with a distance of x. And then reaction at A is 114 kilonewton. So taking the shear equation at segment AB, so we have 114 minus 10 multiplied by x. And then for the moment, at AB, so taking the summation of moment at the section AA, so we have 114x minus 10 multiplied by x, and then the moment arm is equal to x all over 2. So simplify, so 114x minus 5x squared. So we have 114x minus 5x squared kilonewton that meter. And for segment BB, we have 10 kilonewton per meter, and then at 80 kilonewton load that is located 2 meters from the leftmost part of the beam. It is 2 meters, and then we have here x. And the reaction at A is equal to 114 kilonewton. Therefore, the shearing equation at BC is equal to 114 minus 80 minus 10 of x. So it is equal to, so simplify natin. So we have 34 minus 10x. And then for the moment at BC, so we have 114x minus 80, moment arm is x, minus 2. And then for the uniform distributed load, we have negative 10 multiplied by x, moment arm is x all over 2. So simplifying further, we have 114x minus 80x plus 160 minus 5x squared. So therefore, we have 34x plus 160 minus 5x squared. So, arrange ko lang. So, negative 5x squared plus 34x plus 160 kilonewton that meter. And we are now ready to draw the shear and moment diagram. So, same lang. We will extend a line for each segment, and then we will substitute the values of x depending sa location ng segment. So, at the first part, for segment AB, we will use x is equal to 0 to x is equal to 2 meters. So, first part, we have 114 minus 10x, and then substitute natin yung x with 0, so it is equal to 114 kilonewton. And then at x is equal to 2 meters, it is equal to 94 kilonewton. So, there is a decrease of load here. And then at segment BC, we will use x is equal to 2 meters to x is equal to 10 meters. So, at x is equal to 2 meters, our BC or yung force natin BC is equal to 14 kilonewton. And at x is equal to 10 meters on this part. So, it is equal to negative 66 kilonewton. So, makikita nyo yung reaction ng C, it is equal to 66 kilonewton. So, yan, i-close nung 66 kilonewton yung ating shear diagram. So, this is a 0 degree curve. Therefore, yung ating shear diagram would be a 1 degree curve. So, at this part, 1 degree curve. And then, at this part, magiging 1 degree curve then, which is a straight line. So, this is now our shear diagram. And then, if you want to determine the distance of the zero shear again, so, lagay lang natin dito. So, this is, let's say, this is x prime. So, at BC, matatagpuan dito yung zero shear. Substitute lang natin yung yung equation with 0 para makuha natin yung value ng x. That is x prime. Kasi makuha natin x dito will be based at the leftmost part ng ating beam. So, 34 minus 10x is equal to 0. Therefore, x is equal to 3.4 meters from the leftmost part. Minus 2 meters para makita natin yun. So, it is equal to 1.4 meters from segment B. Or from point B rather. So, from point B, matatagpuan natin yung zero shear. And again, at zero shear, doon matatagpuan ang maximum moment. So, for the moment diagram, for section AB, segment AB, substitute lang natin yung x is equal to 0 and x is equal to 2 meters. So, obviously, at x is equal to 0, the moment is 0. And then at x is equal to 2 meters, the moment is equal to 208 kilonewton that meter. And then, again, if you want to determine the moment at the zero shear, i-substitute lang ninyo yung equation natin ng moment of BC. So, substitute lang yung x with 3.4 meters. So, for BC, gagamitin natin tong equation na to. So, negative 5x squared plus 34x plus 160. So, gamitin natin yung at x is equal to 2 meters muna. So, for point B, so we have 208 kilonewton that meter. And for the maximum moment at x is equal to 1.4 plus 2. So, it is equal to 3.4. So, therefore, it is equal to 217.8 kilonewton that meter. So, dito na nakalocate yung ating maximum moment at zero shear. And then, at x is equal to 10 meters, our moment is 0. So, na-close na natin yung ating moment diagram. And then, connect the dots na lang. Since that is 1 degree curve, and the shear is decreasing. So, again, yung sinabi ko kanina, if the shear is decreasing, the moment diagram is concave downward. If the shear is decreasing, the moment diagram is concave downward. Otherwise, if the shear is increasing, the moment diagram is concave upward. So, concave downward, ganito yung itsura ng concave downward. And then, for the shearing stress, if it is increasing, moment diagram is concave upward. So, kabaliktad lang ng ating naunang sentence. So, we have here concave upward. So, kindly take note of that kasi it is very important to consider that in drawing the shear and moment diagram. So, since it is decreasing, concave downward yung shape ng ating curve. And then, same, decreasing yung shear, so concave downward. and then concave downward then up to point D. Kasi yung ating shear is pababa ng pababa. So, concave downward. So, it is important to take note kung anong degree yung ginamit nyong curve. So, during the exam, please specify kung anong degree ng curve. And please make it visible kung concave downward or concave upward. So, draw it visibly kung ano ba yung curve na drawing niyo. So, for the next example, we have here a uniformly varying load or a triangular load at segment AB, and then a load acting at point C, which is 200 pounds. So, it is a restrained beam at the rightmost part or a fixed support. So, at fixed support, we have moment and a vertical force. We will take first the summation of forces. Vertical is equal to 0, upward positive. So, for uniformly varying load, which is yung triangular load natin, we will take the area. So, negative 1/2 of 60 pounds per foot. And then, yung length na is 6 meters minus 200 pounds plus the shear at D. So, it is equal to negative 380 kilonewton. And then, for the moment at D is equal to 0, clockwise positive. So, since this is a triangular load, you should know first how to determine the centroid of a triangle. So, for the moment, we have negative 1/2 yung area, 60 multiplied by 6. And then, we have 1/3 of the length. So, since we are taking the moment at D, consider natin 1/3 of the length of 6 meters. Plus, we have another 2 plus 2. So, 4. So, the centroid is located 1/3 of 6 meters plus 4 feet rather. So, we have feet. Plus moment at D is equal to 0. Therefore, the moment at D is equal to it is equal to 1,480 pounds per foot, or pounds that foot, pounds feet. Moment at D is 1,480 pound foot, and then vertical force at D we have 380 pounds. So we will pass an exploratory section. AA, BB, and CC. So we have 3 exploratory sections. So for segment A, we have the uniformly varying load or a triangular load that is or that has a distance of x feet. So this is x, and determine natin yung value ng y or yung forces that is acting or the force that is acting at y. So we have ratio and proportion kung drawing natin yung triangle. So yung maximum load natin is 60 pounds per foot, and then it has a length of 6 feet. So therefore, through ratio and proportion, we have 60 all over 6 is equal to y all over x. Therefore, yung value ng y natin or yung value ng force natin at exploratory section A is equal to 10x. So, yung y natin is equal to 10x pounds per foot with a distance of x. So, determining the shear at the segment AB, we will take the area, so 1/2 of x multiplied by y. So, yung y natin is 10x. So, simplify, we have negative 5x squared pounds. And then for moment at AB, so we have our area, so negative 1/2 of x, and then yung y natin is 10x. And then the location of the centroid, we have, since dito tayo magbe-base, we have 1/3 of x. Therefore, the moment at segment AB is equal to negative 5/3 x cube pounds. So we have negative 5/3 x raised to 3 pound foot. So for the segment B, so we have here our triangular load. So kompleto na siya. So we have 60 pounds per foot. And then with a distance of 6 feet. And then yung exploratory section natin, we have x. Therefore, we have the shear equation at segment BC. So it is equal to negative 1/2 of 60 multiplied by 6. So it is equal to negative 180 pounds. And for the moment at BC, we have negative 1/2 of 60 multiplied by 6. And then yung moment arm is 1/3. So, yung location na to is 2/3 na. So, this is 2/3 of 6. Therefore, the moment arm is equal to x minus 2/3 of 6. X minus 2/3 of 6 or x minus 4. So, 2/3 of 6 is 4. Therefore, the moment at segment BC is equal to negative 18 or negative 180 x minus or plus. So we have now positive sign plus 720 pounds foot. For segment CC, same process lang. Nadagdagan lang ng isang force, which is the 200 pounds load. So we have here C, and then our triangular load with 60 pounds per foot and a length of 6 feet. And then forces, or a force vertical, which is 200 pounds. So this is now our distance x, and then we have here 6 feet and then 2 feet. So the shear equation for segment CD, so magiging negative 1/2 of 60 multiplied by 6 minus 200. So it is equal to negative 380 pounds. And for the moment at CD, so we have negative 1/2 of 60 multiplied by 6. Moment arm is 1/3 of 6 plus No. So we can say it as x minus 2/3 of 6. So where is this one? So we can say that it is x minus 4, or 2/3 of 6, which is equal to 4. Minus 200, moment arm is x minus 8. Therefore, the moment at CD is equal to negative 180 of x minus 720. So plus 720 minus so simplify pa natin. So we have here negative 380x plus 2,320 pounds foot. So we are now ready to plot the shear and moment diagram. So this is for our shear diagram and this is for our moment diagram. And then same process at shear at segment AB. We will just substitute x with 0 to 6 feet. So we have our shear equation of negative 5x squared. So shear at 0 foot, so it is equal to 0, and then at x is equal to 6 feet, our shear is equal to negative 180 pounds. And then for segment BC, we have negative 180 pounds all throughout segment BC. So all throughout segment BC, we have negative 180 pounds. And for CD, for segment CD, so we have negative 380 pounds. All throughout segment CD, we have negative 380 pounds. So makikita nyo, at the fixed end ng ating beam, we have 380 pounds. And at our shear diagram, at point D, we have 380 pounds. So makikita natin talagang mag-close yung ating shear diagram. So, kindly take note of this naman for drawing or for illustrating the shearing diagram. Kung magbe-base tayo sa load diagram. So, if the load is increasing, especially in triangular loading, the shear diagram is concave downward. And if the load is decreasing, the shear diagram will concave upward. So take note of that. If the load is increasing, the shear diagram is concave downward. So for our first part, concave downward. Concave downward since the load is decreasing. And then we have here a 0-degree curve. 0-degree curve. So ito na yung ating shear diagram. So the first part or the segment AB, it is concave downward since the load is increasing. And then, mga sumunod na is 0 degree curve na. So, this would now be our shear diagram. So, this is a 2 degree curve since our load is in 1 degree curve. So, for moment, same for segment AB, substitute lang natin yung X with 0 and 6 feet. So, at 0, it is equal to 0 moment, of course, and at X is equal to 6 feet, the moment is equal to negative 60 pounds-foot. And then, for segment BC, gagamitin natin yung equation na to. So, we have negative 180x plus 720. So, substitute natin yung x with 6. So, it is equal to negative 360. Tama. And then, at x is equal to 8 feet. So, sorry. So, this is in negative 5/3 x cube. Sorry. It is negative 5/3 x cube. So, therefore, it is negative 360 pounds-foot. And then, for moment BC, so, substitute lang natin yung x with 8 feet and 6 feet. So, at 6 feet, it is equal to negative 360 pounds-foot, and then at x is equal to 8 feet, it is equal to negative 720 pounds-foot. And then at segment CD, so gagamitin natin yung formula natin for moment CD. So we have negative 380x plus 2,320, so substituting x with 8 feet and 10 feet. So, at 8 feet, it is equal to negative 720, tama. And then, at x is equal to 10, it is equal to negative 1,480 feet. So, makikita nyo na close ng ating forces, yung ating moment diagram, since we have a moment of 1,480 pounds-foot at the fixed support. So, again, if the shear is increasing, the moment diagram is concave upward, and if the shear is decreasing, the moment diagram will be concave downward. So, kindly take note of this one. So, the shear diagram is decreasing, therefore, the moment diagram is concave downward. Concave downward. And since it is a 1 degree curve, 0 degree curve, magiging 1 degree curve at this part. So, it is a 1 degree curve, and at this part, 0 degree, so magiging 1 degree curve. So, make it visible yung pagka-concave niya during your exam. Ayan. So, this is now our moment diagram. So, this is a 3 degree curve. 3 degree curve. And then at segment BC, it is a 1 degree curve, and segment CD, a 1 degree curve. For the next example, we have here a beam that is loaded with a uniformly distributed load of 100 pounds per foot. And also, it has a moment located at D with a 120 pound-foot magnitude. So, if we want to determine the reactions at B and E, we will take the summation of moment at E is equal to 0 clockwise positive. Therefore, we have the reaction at B, moment arm to E is 4, 5, 6. We have 6 feet. Minus 100, and then the length is 6 feet. Moment arm is 6 divided by 3, which is 2, or 3 rather, plus 1 plus 1, so plus 2. Plus a moment located at D, so 120 pounds-foot since it is in clockwise direction. Therefore, the reaction at B is equal to equal to 480 pounds. And then taking the summation of forces vertical is equal to 0, upward positive. So we have 480 pounds plus RE minus 100 of 6 feet. And then yung moment arm is 3. We are taking the summation of forces vertical. So, wala palang moment arm. Therefore, the reaction at E is equal to 120 pounds. So, the reaction at E is equal to 120 pounds. And then next, we will pass an exploratory section A, B, C, and D. So we have here 4 segments and 4 exploratory sections, A, B, C, and D. So at the first exploratory section, so same, drawing lang natin yung ating diagram. So we have here 100 pounds per foot, and then distance x. So the shear is equal to negative 100 of x pounds. And then for moment at AB, so we have negative 100 of x multiplied by x over 2. So it is equal to negative 50 x squared pounds foot. And then for exploratory section B, so same process. So paulit-ulit lang yung process na yun. The shear at segment BC, we have negative 100 of x plus 480 pounds. So it is equal to negative 100x plus 480 pounds. And then for the moment at BC, so we have negative 100. Okay, 480 multiplied by moment arm, which is x minus 2, and then 100 x moment arm is x all over 2. Therefore, it is equal to, so simplify pa natin, so we have negative 50x squared plus 480x minus 960 pound-foot. So for section CC, so same process. We will draw the load that is located at the left part of our segment or section CC. So paulit-ulit lang yung process. You only need to master it because on your next subjects, which is the design subject, pinaka-importante yung malaman nyo on how to plot shear and the moment diagram. and of course the shear and moment equation. So this is very crucial for your next subject. So for CD, we have 480 minus 100 multiplied by 6. So we have negative 120 pounds. And then for the moment at CD, so it is equal to 480 multiplied by moment arm is x minus 2 minus 100 of 6 moment arm is x minus 3. X minus 3. So, simplify pa natin. Therefore, we have negative 120x plus 840 pound-foot. And then for our exploratory section D, same process lang. So the only difference here is we have a moment acting at point D. So we have here also a moment of 120 pound-foot that is positive since it is in clockwise motion. And then this is our distance x from point D to C. We have here 2 feet and then 4 feet and then another 1 foot. So for the shear at segment DE, moment DE, we have 480, moment arm is x minus 2, and then minus 100 of 6, moment arm is x minus 3, plus a 120 pound-foot moment. 120. So simplifying further, have 480x wrong, erase natin. So this is negative 120x plus 960 pound-foot. So the moment at T is equal to negative 120x plus 960 pound-foot. So we are now ready to draw the shear and moment diagram. So this is for shear diagram and then moment diagram. So at segment AB, substitute lang natin yung x with 0 and 2 feet. So at x is equal to 0, of course, the shear is also 0. And at x is equal to 2 feet, it is equal to negative 200. It's equal to negative 200 pounds. And then for segment BC, we will use this formula. So negative 100x plus 480, in which x is equal to 2 feet and x is equal to 6 feet. So for x is equal to 2 feet, we have 280, and then at x is equal to 6 feet, we have negative 120. And then for segment CD, we will use this formula. And at segment CD, it is uniform at negative 1. No, it is not uniform. VCD is all throughout negative 120. Yes, this is uniform at segment CD of negative 120 pounds. So segment CD, we have negative 120 pounds. And of course, at segment DE, it is also uniform in negative 120 pounds. So plot na natin. So this is a 1 degree curve. So connecting the dots. And then also this is a 1 degree curve. And then a 0 degree curve. So this is now our shear diagram. This is a 1 degree curve, 1 degree curve. And then we have now the moment. So at the first segment, segment AB, we have negative 50x squared at x is equal to 0 to x is equal to 2 feet. So at x is equal to 0, the moment is also 0. And at x is equal to 2 feet, the moment is equal to negative 200 pound-foot. And then at segment BC, we will use this formula. So negative 50x squared plus 480x minus 960. So x is equal to 2 feet and x is equal to 6 feet. So at x is equal to 2 feet, so negative 200. And then at x is equal to 6 feet, it is equal to 120 pounds foot. And then at moment CD, so gagamitin natin itong formula na to. Substitute lang natin with x is equal to 6 feet to x is equal to 7 feet. So at x is equal to 6 feet, tama, it is 120 pounds foot. And then at x is equal to 7, the moment is equal to 0. So yung moment natin napunta na sa 0. And then at segment DE, gagamitin natin itong formula na to, in which our x would now be equal to 7 feet and 8 feet. So at x is equal to 7, it is equal to 120 pounds foot. And then at x is equal to 8 feet, it is equal to 0. So nag-close na ang ating moment diagram. So if we will plot the maximum moment, gagamitin lang natin yung moment at segment BC. Gagamitin natin yan. So, kung papansin nyo, yung shear diagram natin has a zero shear. So, yung moment diagram natin, magkakaroon yan ng maximum moment. So, the shear diagram is a 1 degree curve. So, this must be a 2 degree curve. So, dapat naka-concave downward siya. So, it must be concave downward. Ayan. This is a 2 degree curve na. That is concave downward. And then, decreasing yung ating shearing diagram. So, concave downward din. Concave downward. And then, 0 degree yung ating shear, so magiging 1 degree curve yan, and then same here, magiging 1 degree curve. Ayan. So, ito na yung magiging itsura ng ating moment diagram. So, kung papansin nyo, it has a peak at segment BC, in which it will occur yung ating maximum moment. So, determine nyo lang yung value ng x doon to determine kung ano yung value ng ating maximum moment at zero shear. So, dito magkakaroon ng maximum moment. So, determine mo yung value ng x by substituting the formula for shear of BC with 0. 0 is equal to negative 100 of x plus 480. Therefore, x is equal to x natin is equal to 4.8 feet located from the leftmost part of the beam. So, 4.8 yan minus 2. So, from segment B, magiging 2.8 feet na lang. So, the zero shear is located 2.8 feet from point B. So, yun nga, if you want to determine the value of the moment, kunin nyo lang yung equation ng ating moment at segment BC, and then substitute nyo yung x with 3.4. With 4.8 rather. So, 2.8. Yan. You must use 4.8, not 2.8. X is equal to 4.8. So the maximum moment will now be equal to 192 pounds. Ating moment diagram. So for our last example, we have here a beam that is loaded with a triangular load and a uniformly distributed load. And this beam is or has a restrained support, so we have a moment and a shear, or a moment and a vertical force at the support. So, if you want to determine the forces acting on the fixed support, we will take the summation of forces vertical is equal to 0, upward positive. So, we have two approaches here. So we have two approaches here. First one is to consider all throughout the 2 kN per meter uniformly distributed load, and then isa-segregate natin yung triangular load. So gagawin muna natin siyang rectangular uniformly distributed load 2 kN meter, and then segregate natin yung natitilang triangle, which is magiging 2 kN per meter na lang yung peak niya. And then other one is to consider it as a trapezoidal shape, but I will consider it with rectangular and triangular shape. So taking the forces vertical is equal to 0, so we have negative 2 kN per meter, and then the length is 5 meters minus yung triangle natin sa taas, which is negative 1/2 of 2 kN per meter, and then the length is 3 meters. Therefore, the value of the vertical force at C is now equal to 13 kN. And then taking the summation of moment at C is equal to 0 clockwise positive para makuha natin yung value ng ating moment at C. Therefore, negative 2 multiplied by 5 meters, and then the moment arm is 2.5 minus yung triangle sa taas, minus 1/2 of 3 multiplied by 2 kN per meter. Moment arm to C is 1/3 of 3. Therefore, the moment at C is now equal to 28 kN meter. So, yung vertical force natin at C is equal to 13 kN, and then yung moment is equal to 28 kN that meter. So, we will task now an exploratory section A and B. So, same process ulit. Drawing lang natin yung segment AB with all the forces acting on the left side of the exploratory section A. So it is equal to negative 2x, and then yung moment natin at AB is equal to negative 2x, moment arm is x all over 2. And then at exploratory section D, so drawing ko na yung rectangular and then yung triangular loading. So therefore, we have here our x, and then maging x minus 2 yung distance ng ating triangular loading. So, by ratio and proportion, kukunin natin yung value ng loading at the exploratory section ng ating triangular load. So, if we will pass the section BB there, we have here x minus 2. Therefore, by ratio and proportion, 2 all over 3 is equal to y all over x minus 2. Therefore, y is equal to 2/3 of x minus 2, or to simplify it further, magiging 2/3 of x minus 4/3. 4/3. Yan. So, we are now ready to determine the shear equation at segment BC. So we have negative 2x moment moment arm, so we have shear pala. So negative 2x minus 1/2 of ating y, which is 2/3 x minus 4/3, and then yung distance is x minus 2, or yung length. So let us simplify it further. So magiging 2x minus 1/2. So yan. So this is now our equation for the shear at segment BC. So, may mali tayo dito. So, kindly take note of this. So, negative 4/3 pala. Not 8/3. And for the moment at BC, so we have negative 2x, moment arm is x all over 2. And then yung triangular loading natin, minus 1/2 of 2/3 x minus 4/3 multiplied by x minus 2. And then yung moment arm niya is 1/3 of x minus 2. Moment arm is 1/3 of x minus 2. So let us simplify it now. So kindly bear with me kasi masyadong mahaba, medyo mahaba tong solution na to, or yung simplification ng solution na to. So we have now the simplified equation for the moment at BC. So we have now our equation for shear at BC, segment BC, and moment at BC. And we are now ready to plot the shear and moment diagram. So for the first part, for the segment AB, our x is equal to 0 to x is equal to 2 meters. So yung nasolve nating equation for segment AB, we will substitute lang with x is equal to 0 and x is equal to 2 meters. So shear ng AB, so at segment or at point A, of course it is in 0 shear. And then at point B, magiging negative 4 kilonewton. And then for segment BC, dito na tayong part. So we have here, sasubstitute lang natin yung x with 2 meters and 5 meters. So at x is equal to 2 meters, our shear is equal to negative 4 kilonewton. So tama. And then negative 13. So may makikita nyo yung ating load diagram, we have 13 kilonewton upward. And ang shear diagram, we have negative 13 kilonewton. So mako-close yung ating shear diagram. So at the first part, it is a 0 degree load diagram. Kaya magiging 1 degree curve ito. And then at this part, since it is a 1 degree curve, magiging 2 degree curve ito that is concave downward. Kasi as I have said earlier, that if the load is decreasing, the shear diagram is concave upward, and if the load is increasing, the shear diagram will be concave downward. So concave downward yan with a degree of 2. At second degree curve yan. 2 degree curve. So this is a second degree curve. And for the moment diagram, gagamitin lang natin to. Substitute lang natin yung x with 0 and x is equal to 2 meters. So of course, moment at A is equal to 0. And then moment at 2 meters, so it is equal to negative 4. Maging negative 4. And then at BC, so kindly take note of that. Medyo may correction tayo sa pag-simplify kanina. So, kinorek ko na yung equation natin. So, kindly solve it again na lang para makita niyo kung anong correction dyan. So, we have a definite error there. So, pinalitan ko na. So, doon na balik tayo sa moment. So, moment at BC at x is equal to 2 meters and at x is equal to 5 meters. So, at x is equal to 5 meters, it is equal to negative 28 kilonewton that meter. So, kung makikita nyo sa ating load diagram, we have there clockwise moment na 28 kilonewton meter na mag-close sa ating shear moment diagram rather. So, at this part, decreasing siya concave downward. Since the shear diagram is decreasing, the moment diagram will be concave downward. And it is a 3 degree curve. So, yung curve na to now is in its third degree since yung shear diagram natin is in second degree. So, this is in first degree, second degree curve, and this would now be third degree curve. So that's it.